and testing embedded applications. This is Ranga Reddy from SP Software. So I will be discussing and presenting the features and benefits of uh, IBM solution for testing embedded and real-time application. So before going to present this, just I want to introduce my company for about 1 or 2 minutes. So we are from SP Group of Enterprises. So one of our company is SP Software. So our it is started in 1995 with a vision to exceed the expectation of our customers. So with a mission to provide integrated and cost-effective state-of-the-art quality solution for our customer satisfaction. So we have a clients about 400 and an employees touching around 600 and a revenue about 20 million USD. And SP Group consists of SP Software Private Limited, SP Soft Digital Media and Embedded IT Solutions. So now we are representing from SP Software Private Limited. All are based at Hyderabad. So we are working with Oracle, IBM, Microsoft, Sony Qual, Cron, Lenovo, HP, Red Hat, a lot of other software also. So as far our quality journey is concerned, we are already CMMI level 3 and trying to implement CMMI level 5. So we are already certified ISO 9001 2000, ISO 27001 2005, 9001 2008. And if you see, our diversification is into financial services, retail, utility, manufacturing, gaming, telecom. So we have partnership with all these vendors like Microsoft, Oracle, IBM, Qualcomm, L&T, and these are the partial list of our customers, and these are our alliances, partnership with this company principals. Now coming back to our rational test real time, so providing you solutions for embedded application solutions. Now I will be focusing on to call, sorry, let me open this presentation. Yeah, now rational solution for automobile industry. Now in this presentation my agenda is trends in automobile industry faced by suppliers, best practices to accelerate component delivery with maximum flexibility, and what is the rational solutions, followed by a demo. If we see component evolution in automotive industry, there is a gradual increase of the various component facilities provided in the automotive industry. If you see from 1980 to current developments, so there are a lot of components being added with the new technologies, which is making the complexity of this application developments for this industry. So these complexities can be tested and have a solution with IBM Rational Test RealTime. It has cross-platform testing solution designed for embedded applications. Basically it automates your testing for analysis and bug solving early during development stage as well as testing. So it is having low overhead technology called target deployment port to enable the testing activities. It extends model driven development also testing. Basically we have our Rhapsody, which is used for model driven development. This tool can be integrated with that tool to make models to be tested during the development. Alright, so we come across the main features of this product. So it is automatic component testing template can be created using this tool. We have black box and white box testing, so we can test the components at all levels of complexity from single function to distributed functions, and there is a static metric calculations with it, so which can give you the complexity of code, and there's a Mr. C review, code review. If you look at the snapshot of automatic component test template for writing test cases for component testing, this looks like this. You can see a test case with some variables initialized and with some expected values, right? So before testing, you can have a test priorities based on this metrics provided by the tool. If you can see this, there are a lot of functions, so each function is calculated and giving a complexity matrix, and there are how many statements are there in this each function, and the nested levels. So based on this information, tester can prioritize their testing. So it is also calculates the complexity estimation. So if you see the right hand pan is a project browser, and leftmost browser is a asset browser. If you click on each file, it will give you the corresponding metrics, which can help you to plan your testing activities. So apart from this, it can also provide the full regression testing. So the main features of this product are code coverage, memory profiling, performance profiling, runtime trace, and thread profiling. Let me show you some snapshots how code coverage will look like. So this is the code that you can see in two colors. One is green and red. Green portion of the code shows you the executed code, and red one is not executed. And memory profiling, it identifies the memory leaks on a heap area. So it gives the memory leaks in two forms. One is block summary and the other one is byte summary. So block summary gives you how many blocks are allocated in the application, and byte summary gives how many bytes are allocated. So the blue color index tells you the what is the maximum allocation, and yellow one tells you how much memory is being used, and red one shows you what is the memory unfreed. Apart from that, there are a lot of other memory leaks that it can detect, like file descriptor and signals, and IBW late detect array bounds, early detect array bounds. Like there are various types of memory leaks that it can detect. So other feature is performance profile. Performance profile will tell you the execution time of each function in your application. And runtime tracing is one more beautiful feature. It gives you the pictorial diagram in the form of sequence diagram. It gives you what is the call time of each function and exit time of the each function. Apart from this sequence diagram, you can also see the timestamps at each entry and exit of the function. It will help you to uh, know the sequence of operations that happen during the execution of the application. If your application is a multi-threaded application, you can also find the thread profiling, which tells you with status of each thread, whether it is sleeping, running, waiting. So what is the status? So these are the main features that this tool can provide you apart from the unit testing. When you do all these things, so it will give you a consolidated report. So this is the unit testing report. So if you see the variables, there are two variables x and buffer that are shown in green color. The box shown in green color, you can see there are two variables x and buffer. So there are three rows, rightmost rows, initial value, expected value and obtained value. Based on this information, a tool can tell you whether the test case is pass or fail. If you see the left hand pane, and that you can see all the test cases. When you click on each test case, you can see corresponding result information on each test case with what are the initial expected values provided, whether it is fail or pass, right? And if I summarize all these things, so component testing can be supported by C, C++, ADA and Java. So it is having code runtime analysis features like code coverage, memory profile, performance profile, runtime tracing and thread profile. Apart from all these, we can also do the system testing. So this tool is qualified for TIVO 178B or code coverage and MESRA C and some other defense standard. So tool is supported from 4-bit to 64-bit cross development environments. There are few are named here: Wind River, Green Hill, some like this. And the platform supported Windows, Solaris, Linux, HP and AIX. So there is a beautiful provision provided here is target deployment port, which can give you the customization of this tool for any kind of embedded application environment. So this is a customizable to support complete range of embedded targets. Assures tool adoption, reduces your ramp up time when target configuration changes, guarantee the reuse of test asset despite target constraints. The host, build and target environment agnostic. So it ensures the portability and simplification and good optimized ROI. You can also optimize the size and speed to certain limit. So whatever till now we discussed is related to our runtime analysis features. Now I will be focusing more on component testing. So component testing, I will be morely focusing on C language. Now this is a source code driven, data intensive functional and structural testing using function calls, and it is automatic because it generates test template automatically from the source code. So test data generation from pattern language, and you can also create stubs. So you can also perform regression testing. and once you've done this testing, it generates a detailed reporting. Apart from this dynamic analysis, we can also do the static metrics for test prioritization, and we can work with runtime analysis features along with your unit testing. Now if you look at the test harness architecture of this tool, there is a test driver which can drive the test, which checks the written parameters, access global variables. Another part is stub. Stub checks the input parameters, return desired patterns. Now what about stubs? So stubs are unavailable portions of your source code. If you see the component testing process, that means mechanism inside. So see, the coding part will be done by the software engineer, and tool will generate the template, and then script will be edited by the software engineer, then test harness will be executed, test results are generated. So once test results are generated, any fix can be done by the software engineer, again redoing this activity. So test enhancement to the test, and if you see the test script pattern, if you can see, there are A, B are the variables. We have initialized that variables, and EV is the expected values, right? And this pan shows you the function under test. We are doing an addition, right? And this one is a test script template, and these are the default values for the particular function to be tested. And this is the function to be invoked for execution. So if you see the test case, a typical test case is having a element block, and element block is contain lot of other variables which are there in the function to be tested. So if we look at this slide, so there are various ways of assigning the values to the global variables. So if you look at globe is a variable initialized with 0, and y is another variable initialized with 3 values. That means we can assign a range of values. Another one is an array. A is an array of size 10. So there is a incremental value given 1 from 1 to 1000 with increasing 1. And Z is a structure with field is as one of its element, and BC as other variables. Like this is the various ways of giving test inputs. And once the test is executed, it can generate the test reports, so which is easy to understand, passed and failed test cases at a glance, because it gives a color index, initial and expected obtained values for all managed variables and stubs, and source code coverage also we can see here. Once you analyze this test report or you are okay with it, you can export this to HTML for a distributed development and test contracting. And there is a one provision to test the consecutive tests, right? This is the test done for the first time, and you modified the script and rerun, you got another value. So if you look at this expected value, obtained value comparison, that is an earlier execution, right? This is obtained value is 99. Now after this execution, second time execution, we got different obtained value, which you can see see for the comparison. Now I will show you the demonstration of component test, how it can be performed. I will show you different types of component testing, like giving values to structures, pointers, arrays, strings. Apart from this, how to import the input values from a file, right? So let me close this and open the RTRT Rational Test RealTime. This is my icon. I'm opening, double click. Okay, now this is a dashboard of RTRT. So if you can see here, new project from the template, open project. These are the three things available. If you see left hand side, there is a welcome, hyperlink, get started, activities, examples, support and targets, right? Let me open the base station. So now I have a ready-made project called base station. There are two nodes. One is base station, this is runtime analysis node, and UMTS code, this is for component testing, right? So let us look at how to run this.